So on problem 105, write the equation for a line that passes through the points 2, 0, and 0, -3. Remember to draw a diagram, it might be helpful. So if you want, you can draw a little diagram. How many points does it take to make a line? 2. So just kind of making it be perfect, right? So if we plot these points, how do we plot 2, 0?
On the 2x of the x-axis.
Yeah, goes alphabetically, so x is first and then y, so 2, 0, so we're going to go over 2 and up 0. And then how are we going to plot 0, -3?
0 down 3.
Down 3, right? And any 2 points make a line. So our line looks like this. So now we need to come up with an equation. So what's probably the most common equation for a line?
3 over 2 plus y. Yeah.
Y equals mx plus b, right? And if we go through y equals mx plus b, x and y, those are all of the points that are on the line. M stands for slope, and b is your y-intercept.
So these
So if we just look at our line, should our slope be positive or negative?
Positive.
Should be positive, right? Because it's going up. So we at least know to keep that in mind. So our line is made up of a whole bunch of points. So that's kind of where our x and y fall. So we're just pretty much going to leave that x and y. Because on this one, B stands for, what's B stand for? Y-intercept. And by definition, y-intercept is where it crosses the y-axis. And do we know where it crosses the y-axis? It crosses at -3. So we got our y, we got our equals. We don't know m yet. We know x, and we know our b is -3. So we just need to figure out our m. So how do we find slope?
rise over 1.
What's rise over run mean?
It's like up over.
Rise over run, or up over? All right, so how do we find those?
Starting at 3, go up 3.
So it's like, how many steps would you go up? Well, I actually don't know which one is which, but you know, up.
How many up?
The 3. And then 2, but I don't know.
And
how to
then-
explain it.
How many?
Yeah, there we go. How many steps up the y-axis?
So how many steps up the y-axis over?
Well, I feel like we can't say y-axis because then we won't say over 2, but it could be like.
How many steps over the x-axis? Yeah. So do I always have to go off of my y-axis? So I have to go from here?
No, you can do like -2, -3.
Negative,
Well,
like
you,
-2, -3, is that what you're saying right there?
No, I was thinking like if you start.
Oh, from that point, you're right, yep. So when it comes to finding slope, another way to think of it, like this rise over run or ups and overs and all of that, is you're figuring out your change in y over your change in x. So if I go to the store and I buy something for $5 and I give them $20, how much change am I gonna get? $15. How'd you get $15?
20 minus 5.
20 minus 5, right? So if we see that word change, we're thinking of the difference or subtracting the numbers. So if I'm looking for my change in my y, if I look at my points, can I subtract those two from each other? Yeah, yep. So do we want to do the first point And it doesn't matter. You can do the first one minus the second one, or you can do the second one minus the first one. Which way you want to go?
Second minus first.
You want to do second minus first? So then we would be doing -3 minus 0, right? So when it comes to that change in x, we're just subtracting our x's. And this is just the only part that you got to be careful on, because we went -3 minus 0. So we have to go 0 minus 2. So you got to keep the order the same. So 0 minus 2. So what's -3 minus 0? -3. Yeah. What's 0 minus -2? -2. So what's my slope going to be? 3/2, positive 3/2, right? So negative over negative is going to be positive, right? And is that a positive slope that we're looking for? Yep. So if we had a negative slope, we'd be like, whoops. Right. You guys got any more on the homework? All right. So we just have like 2 problems to talk about today. So you guys didn't get assigned problems 108 or 109 because we figured we'd do those in class together with everybody. So problem 108, it says make a sketch of a graph showing the relationship between the number of people on your school's campus and the time of day. So the number of, pardon me? Yeah, so the number of students on campus and the time of day. So we're gonna make a graph. So before you guys draw out your graph, do we need a graph that looks like this? No. Right, because like technically your y values are negative down here, and can you either have negative students or negative time? No, and kind of the same thing over.
Oh, you could say I need this much more. Wait, no, not even.
Right, but still, if you need more time, it's still like we're not back to the future. We haven't created a, what was that thingy called? The super flux capacitor. The what?
I never watched that.
Yeah. Let me tell you, there was I don't know. I can't even tell you because I don't even know. But like I made like some statement and like somebody came back with some, you know, like flux capacitor, whatever from the movie. And I'm like, okay. And like I just kind of, and they're like, do you not know what I'm talking about? And I'm like, no. And they're like, haven't you ever seen Back to the Future? And I'm like, yeah, I've watched it. And they're like, you don't know this part? And I'm like, I don't know. I guess I didn't pay attention that close. So yeah. So maybe that's what I'll do this weekend, right? All right. So because we're talking about time and students, we are only talking about positive things. So we only really need that first quadrant, right? So we just need this little guy over here. So anytime we go to make a graph, we need to do what? What do you think? Starts with an L.
Label the, that's what I was gonna say.
Yep, label the axes, right? So do you think time depends on students or students depend on time?
Students depend on time.
Huh? Yeah. So we're gonna put
Independent variable. Students are dependent variable.
put time on the bottom. Number of students. Right. So we don't need to sit there and actually, we're not going around and we're not counting how many students are here and putting the date. We just want like a rough estimate on what this graph would look like, right? So before school starts, how many students are we gonna have?
Probably 0.
Probably 0, right? I'm hoping nobody's staying the night here, right? Hope nobody got locked in the locker room and couldn't get out. Right. Well, considering the doors only lock like coming in,
Yeah.
you can always get out, right? All right. That was close enough, right? All right. So we know we're gonna start. We at least got a point at 0, 0. And somewhere on our timeline, what's going to happen to all of the students? All the students are going to,
Go home.
they're all going to go home, right? So we know that we're going to be on that x-axis twice, but we need to figure out what to do in between. Okay? Yeah.
Yeah, but there's no number.
Right. So we know we're going to go up. Are we going to go up fairly sharply, or do you think you're going to go up slowly?
It's gonna love. Think about it. When we walk in the door in the morning, there's like groups. Like when the bus gets here, you finish your up with it.
Yeah. So do we want to like show like as each bus comes in, or we just want to make a generalization? Yeah. I'm going to say we're going to go up, right?
We're gonna do the least amount that we need.
Right. So that's in the morning, right? The buses are showing up, people are getting dropped off, people are parking and walking in. Then what happens?
Then we're there.
It steadies out. It steadies because people are here for how many?
Well, then the GCI kids get here.
Oh, yeah, that's true.
Oh, GCI kids?
GCI kids get here at the third hour.
Yeah.
Okay.
Go up, but then it goes back down because some people leave.
Yeah, because the mock kids go to mock.
And there's GCI second session.
So then you go back down.
All right, well, wait, hold on. If I go back, do they leave at third hour? Do they come and leave at the same time?
Yeah.
So if they come in, but if I do this is just saying that they show up and then a group leave.
It's a different.
It's a different group of people.
But is it at the same time?
Yeah,
No.
But it's at the same time, so.
They
They
don't. No, they already have to be there when we leave GCI, so they're already there, so they already done lunch before.
Oh, okay.
This is just too much.
Some people go. and
Right. We're gonna say the same, right? All right. So then lunchtime comes and we gotta close campus, so nobody's going, right? We could put a little dip in there. We'll say that, right?
They send a lot of people home due to COVID. So.
I know. So we're gonna sit there and act like it's last year. Right? All right. So these are just the students that are dual enrolled in GCI, but nobody came back. We're just gonna say, right? And then that's gonna level off, and then what's gonna happen?
It's gonna go down.
It's gonna go down. And hey, maybe we got some sports, so it might kind of come down slowly, right? And then everybody's out. Right. Everybody's graph can look a little different, right? This is just kind of a generalization. I wanted to put the hoop in there. I just said you guys all showed up, you stayed here until the end of 6th hour and you went home. Right. All right. And then you probably should put a tail or a title on this. Right. Right. So what? No, you can't write graph. So number of students in school for the day, right? For the day. You know, let's get a little extravagant. Who knows, right?
What about the Saturdays and stuff? Now
Well, what would that graph look like?
I have it here on Saturday.
Well, sometimes we don't go into the school, do we?
I take a pee. Last Saturday I took a pee. Wait, did I?
Is it peaceful by yourself?
I don't know, no one else would
Right,
have
yeah.
it.
All right.
Might have been last year.
I see, I remember.
I don't know.
All right.
Did I take a
Number 109. Let me tell you, I used to teach upstairs, like when I first hired in. Was it when I was upstairs? Yeah, it was. And I had like an emergency situation kind of like come up, so I had to get up here and like drop off. This was like before technology, and had to drop off lesson plans. So it was dark when I came up here to do it because I couldn't come in that next morning. So and at that time, like, I don't know, like all of our keys worked to get into everything. It was just different time. Huh?
It wasn't the alt, it was just your classroom was upstairs?
Yeah, my classroom was upstairs, right? But because it was at nighttime, there was nobody here. And like, there's no light switches in the hallway because they're all those funny keys. It was crazy. So like upstairs, I mean, the upstairs is just like this downstairs, right? But where the bathroom is, there's an exit sign and it has that red glow light, you know? So I had to come in all the way down there and go up the stairs. And then my room was this very last one. So I'm walking down this hallway and it's just like,
It's red.
right, it's like pitch dark, but it's got that red glow. And only thing I could think of was like every single horror movie. And somebody was gonna jump out of the bathrooms at me, and I'm like, just keep walking, just keep walking, just keep walking.
You just see this bitch come diving out.
Right, yeah, I know. Yeah. Yep. It is, yeah.
I would've made
So I hurried up, got to my room, and I turned the light on.
I would've ran. There was no walking.
Yeah. So then I ended up going out the side doors and walking in the front of the school because I felt that was safer.
The school feels different after school hours.
It does.
It feels really weird.
It does, yes, yes. All right. So question 109. 109 sat there, they gave you guys 3 different graphs and they wanted you guys to find the domain and the range. So domain and range. So if I'm looking for domain, I'm looking for what values?
The X value.
X values. Yep, good job. And if I'm looking for the range, I'm looking for my Y value because we need to know. That's why. All right. So in a nutshell, A looks like 1, 2, they go from -3 to 3, and then up 3 and down 3. Right. This is in your book, so it looks nice and looks better in there. And then they got 1 that goes to like here, then they drop down. Anybody remember what these little functions are called when they look like this? It started with an S. Yeah. Do they kind of look like, what was it? Did you say,
Split.
almost split. Steps. They're called
I
step
guess they're like a
functions.
timeline. You know how like
Uh,
my history goes?
Oh, yes, right. Yep. So when it comes to looking for our domain, we'll start with domain. So we're looking at our X values. So I just kind of go down my X axes, going smaller until I find the smallest value. So like at -1, we got a graph. But if I go to -2, we still got a graph. If I get to -3, I still have a graph, right? If I go to like -4, do I have a graph anywhere?
No.
No. So what's my smallest X value gonna be? At -3, right? And then I'm gonna do that same theory, but I'm gonna go positive, right? Getting my X's where my X's are getting bigger. Do I got something at 1? Yep. Do I got something at 2? Yep. Do I got something at 3? Do I have something at 4?
No.
No.
Well, if you see the graph, it's already like only back out to 3s. Can you just be like, oh, it's starting here?
No, but they kind of cheated a little bit when it came to the Y's. Yep. So when it comes to filling in my inequality, I know that -3 is my smallest, and they have that circle filled in, which means that I can be 3, so I can equal 3. So -3 is less than or equal to X. But when I get over here to +3, I have that open circle. So that open circle means I can get really close to it, but I can't be it, right? So X is gonna be less than 3. Then you got the same thing going on when it comes to range, but range is looking at your Y values. So same idea. I start going down my Y's to see where do I have a Y at -1?
No.
No. Do I have a Y at -2?
C.
Yep. Do I have a Y at -3? No. So this one's a little different. Do I have a Y at 1?
Yes.
Do I have a Y at 2?
No.
Do I have a Y at 3?
Yes.
Yeah, right there, right. Sorry, yeah. The book does a better job than I do, right? Do we have one at 4? No. So this one's a little different. We're not going to have an inequality because we only have our Y value at 3 values, right? So we have our range when Y equals -2, when Y equals 1, and when Y equals 3. And of course, they had to give you more than one little graph. So then we got 1 at 2. And you have a vertical line right there. So when it comes to our domain is our what values? X. So I'm trying to find X values. Do I have anything at 1? Do I have something at 2? Yeah. Do I have anything else other than that 2 for X? No. So my domain's going to be where X equals 2. Range is my Y values. So I'm going to go down. What's the smallest Y value I have in my graph?
Oh, wait, never mind, isn't that the one
Oh,
problem?
yeah. So here might be -3, but I'd have one at -4. What's the smallest I'm going to find? Is this going to keep going down forever?
Yeah, so it'd be infinity.
Yeah. What kind of infinity?
Negative.
Negative infinity. Oh, see, I can't draw it today now.
I cannot draw.
Nobody does. What's the largest Y value I'm going to find? Infinity. Yeah. So we know that Y is going from infinity, negative infinity to infinity. Can you ever be infinity?
No.
No.
there's something after it.
Right, because you can go beyond, right? So we got our inequality in there, right? Infinity is less than Y, and Y is less than infinity, but they can't be equal. Not too bad? All right, so you guys have some closure problems to do. So at the end of the chapter, it's problems 119 to 127. So, and it has to do with all types of problems that we've done through the chapter. So those are the ones that you're gonna wanna make sure you are able to complete and do. Right? If you can, pardon me?
We don't have to turn 108 or 109.
Nope, 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 nope. Those are just part of like your notes. Nope, 108 and 109 don't need to be turned in.
Alright.
Yep.
So,
You're welcome.
do you remember when I'm confused? Like, if you had